Okay, we're continuing on with lesson 3.6, and this is video 3. We want to prove the sequence for x sub n is equal to 1 over n for n equaling is 1, 2, and so on, continues on. It's an infinite sequence. Is a Cauchy sequence, and we'll abbreviate Cauchy sequence as CS. So here's our proof. Okay, so our proof is we have the sequence x sub n is a Cauchy sequence if for all epsilon greater than 0 there exists an n that is a positive integer, but we have to find, normally we would choose an n, but we don't know what that n is. So we're going to have to do some scratch work, find what n is, and then we can go back and write our proof. But we can continue on where all sequence, the sub n and the sub m in our sequence are elements of the natural numbers or counting numbers. And our sequence n is greater than our n, what we set our limit, and also m in our sequence is also greater than n. So on here we're saying that x sub n is beyond this limit. Wherever we set this limit for n, our x sub n and x sub m are beyond that, so that we can be within epsilon. Okay. So this implies that the difference in our x sub n minus x sub m is less than epsilon. So the difference between these 2 points are going to be within the range of epsilon. Okay. And so that they would eventually converge to a limit. So what we need to do at this point is we need to develop our scratch work. Okay, so we'll use purple for that. So scratch. So we have to come up with our scratch. We've got to find what n is first, and then we go back and write our proof. So here we start with this, right? X sub n minus x sub n is minus x sub m is less than epsilon. So since our x sub n is 1 over n, right, we can put 1 over n in there. And since we're using m for the other one, we would make this 1 over m. 1 over m. And that's all less than epsilon. Okay, so now we can change this to 1 over n plus the parentheses, the quantity 1 over m. And so from here we can go ahead and use the triangle inequality. And again, to kind of go back over that, if we had a vector of A and a vector of B, we get those two added together, A plus B. Well, this side is going to be less than the sum of the other two sides, so the absolute value of A plus B is less than or equal to the absolute value of side A plus the absolute value, the magnitude of A and B. So if we're looking at vectors here, right, these are magnitudes. So the magnitude of side A and the magnitude of side B is greater than the magnitude of the two vectors added together. So we can do that here as well. So this is going to be less than or equal to the magnitude of 1 over n plus the magnitude of negative 1 over m. Well, that's because it's absolute value, we can just change that to 1 over n plus 1 over m, like that. And since these are absolute value, we know that they have to be positive, so we can just drop the absolute value, and so that's just 1 over n plus 1 over m. And since we want to make all of that less than epsilon, so let's examine each one of these separately. Since 1 over n plus 1 over m is less than epsilon, then since 1 over n plus 1 over m is less than epsilon, then then we can say that 1 over n is less than, we'll say epsilon over 2. So let's say we divided these up and we got epsilon over 2. So if we were to go ahead, we can multiply the n and divide epsilon, or we could just flip them, apply the reciprocal to both sides, and so that becomes n, and we would switch that inequality to greater than 2 over epsilon. So in other words, instead of cross multiplying, right, and we got 2 times 1 is less than epsilon times n, and then divide epsilon, and so this would be 2 over epsilon, right? All I did was just multiply the reciprocal and change the inequality sign. Well, you could do the same thing for 1 over m is less than epsilon over 2. Since 1 over n plus 1 over m is epsilon, then we could just say that 1 over n is less than epsilon over 2 and 1 over m is less than epsilon over 2. So again, we apply the reciprocal. M is greater than 2 over epsilon. So from here, we can say that since we said up here, since we said here that m is greater than n, and the sequence m is greater than the n we set for our limit here, and n is also greater than our uppercase n, then we can say that we can choose an n to be greater than 2 over epsilon, because lowercase m is greater than n, and that's greater than 2 over epsilon. We can say, and 1 over n, or n is greater than uppercase n, and we can set that uppercase n to be greater than 2 over epsilon. So now we have our n. Now we have our n. Where are we? Where is it? Here. Now we have our n, and we can write our proof. So now we can go back and we can write our proof. So here's our proof. And so here's our, now we can write our formal proof. And so we would start this all over again, and we would rewrite this here for our formal proof. We have a sequence x sub n is a Cauchy sequence if for all epsilon greater than 0 there exists a uppercase n that is part of our we said it was part of our positive integers. We choose n to be greater than 2 over epsilon, okay, where all n is nm. I'm trying to squeeze this in here, are elements of the natural numbers, and our sequence n is greater than our number n, and m is greater than our number n for our absolute value of x sub n minus x sub m is less than epsilon. Okay, so we're trying to prove this. So once we get to epsilon, then we've proven it. Okay, so from here we go back through our steps again. So basically we're here, right, and we're putting in 1 over n minus 1 over m, that's less than epsilon. Okay, so we're just going through this whole sequence all over again, and so we can say 1 over n plus the quantity negative 1 over m, and that equals to so here this is 1 over n. So now this would be less than or equal to 1 over n plus the absolute value of negative 1 over m, and so that becomes positive. So that's the absolute value of 1 over n plus the absolute value of 1 over m. And so because these are always going to be positive, we can drop the absolute value, and so from there this is going to just be 1 over n plus 1 over m, and since so 1 over n, since 1 over n is since n is greater than uppercase n, then we can say that 1 over n is less than 1 over uppercase n. Why? Because the larger the denominator, the smaller the fraction. So 1/3 is smaller than 1/2, right? So if this is larger, if n is larger than uppercase n, then the fraction is going to be smaller because these two numbers are the same. So if n was 3 and lowercase n was 3 and uppercase n was 2, then 1/3 would be less than 1/2. Okay, and since and actually, and since m is greater than uppercase N, then 1 over M is going to be less than 1 over N. Okay, therefore, in that case, then we have 1 over N plus 1 over M is going to be less than 1 over N plus 1 over N. Since this is less than 1 over N, then, and 1 over M is less than 1 over N, then 1 over N plus 1 over M is going to be less than 1 over N plus 1 over N. And since we said that N, since N is, we said N is greater than epsilon over 2, then we can say that this is going to be less than 1 over epsilon over 2 plus 1 over epsilon over 2, because N is epsilon over 2. So 1 over N is going to be 1 over epsilon over 2. Okay, so here, because, so let's look at this. So this is what we've got. We've got 1 over epsilon over 2 plus 1 over epsilon over 2. So that's like saying 1 divided by epsilon over 2. Well, we're dividing fractions. We multiply the reciprocal, right? So that's 1 times 2 over epsilon. Or, oh, so this should actually be, because N is 2 over epsilon. N is 2 over epsilon. Okay, so back up. Back up. Where did I mess this up? Since, okay, here. I'll back it up even further. Okay, so since 1 over N plus 1 over M, since that's gonna, so this will be, since N is greater than M, then 1 over N is going to be less than 1 over N. And 1 over M is going to be less than 1 over N. Because if this is, let's say N were 3 and in uppercase N were 2, then when you apply the reciprocal, so now this would be 1 over 3 and 1 over 2. So 1 over, the larger the number, the smaller the larger the denominator, the smaller the fraction. So in that case, since N, since uppercase N is greater than, we said 2 over epsilon, 2 over epsilon, then we would say that this is less than 1 over N plus 1 over N. So we're saying that 1 over N is less than 1 over lowercase n is less than 1 over uppercase N, and 1 over M is less than 1 over uppercase N. So therefore, the sum of these is going to be less than 1 over N plus 1 over N. And we said that since N is 2 over epsilon, then this is going to be 1 over 2 over epsilon plus 1 over 2 over epsilon. And so if we had here, if we're dividing fractions, right, 1 divided by 2 over epsilon, that would be the same thing as 1 times epsilon over 2. So all of this is going to be less than epsilon over 2 plus epsilon over 2. So all that equals 2 epsilon. And so we're saying here that all this, all the way back, goes all the way back to here. We're saying that the absolute value of x sub n minus x sub m is less than epsilon, and we've proven it. And that's our video.